Okay. Good day, everyone. This is Mr Sithole, okay, from Emerald Private Tutors, as you can see displayed on the screen. Okay, so today's the topic is momentum. Okay, it's momentum, grade 12 momentum. And what we're going to do in momentum today is we're going to have an understanding of what is momentum, what is actually momentum, and we're also going to look onto Newton's second law, and you're going to look also on impulse. Okay, so we want to understand what is momentum and what you need to understand when you're talking of what are we talking about when we're talking of momentum. Okay, so momentum is a measure of an object, the amount of motion. Okay, a measure of an object of its amount, measure of an object, the amount of motion. So we're talking of we're talking of an object with a mass and a velocity. So because remember, anything with a mass and velocity does have momentum. Okay, so it has to be a moving object. It mustn't be stationary, because once it is stationary, then it's not momentum. Okay, so let's get to see what I'm talking about here. Okay, let us see what I'm talking about here. Okay, so what we have here is that we have momentum here, and we're saying momentum is actually for objects. It must have what we call all objects with momentum. All objects with momentum and velocity have what we call with mass and velocity have momentum. Okay, so our mass must be in kg. Our mass must be in kg, and our velocity must be in meters per second. Okay, so we have velocity, and velocity is saying the speed, and your speed here, because velocity is a vector, okay, it does have a direction. That's the only difference with speed. Okay, but otherwise in terms of magnitude it's just the same. Now here, magnitude and direction in terms of what we call when talking of velocity. Okay, now then we have momentum. So therefore momentum is actually of an object is the product of mass and velocity. So momentum is represented as momentum okay, is equal to mass times what? Velocity. Okay, and momentum, remember we said our mass is in kg and our velocity is in what? In meters per second. Therefore, our measuring unit here for momentum should be kg meters per second. Okay, kg meters per second. That's what you must understand. So whenever you're given your any scenario, you must make sure that you convert the object mass to kg. Object mass must be in kg. That you must have a look out on that. Then object the velocity must be in meters per second. So let's see here. When it's given in grams, what must you do? You must always divide with what called 1000, because remember there is in 1 kg is equivalent to 1000 grams. Okay, 1000 grams. Then when you talk about velocity, velocity should be measured in meters per second. And remember, when you're saying meters per second, just basically meters over seconds. Then we want to see what if you're given 1 kilometer per hour, 1 kilometers per hour. What are you supposed to do? You are supposed to know that. All right, you're supposed to know that your kilometers, how many meters in a kilometer? 1000 kilometers. How many seconds in an hour? 60 in 1 minute, and 60 in an hour. 60 minutes in an hour. Okay, so we have 60 times 60, then it brings what called 3600. So whenever you're dealing with what you call with with anything that is given in meters per hour, in kilometers per hour, you must always multiply it with what called with 1000 over 600. Let's see how we can simplify 1000 divided by 3600 and see what we get there. We get that, but what about is a fraction? We get 5 over 18. So let's have an example here. If anything, let's say you're given 100 kilometers per hour, 100 kilometers per hour. 100 kilometers per hour. So if you are given 100 kilometers per hour, what must you do when you are given 100 kilometers per hour? You must multiply it by what? By 5/18. Let's see here, 5/18. That's our answer. Okay, times what? Times 100. And we want to see what we get here. We get 2. So we get 250/9, which is equal to the decimal 27.7 meters per second. So you must always know that my unit must be in meters per second. And remember, we are talking of momentum here. Momentum. So when momentum here, momentum is actually represented as P, and we say it's equal to M times V, which is mv. Okay, so we say it's M times what called is equal to M change in velocity. Because remember, all objects, even if there is a collision, remember they will be changed in velocity, not change in mass, but change in what? Change in velocity. So let's have an understanding here with it. What must you do when you're doing calculations? When you're doing calculations, remember mass in kg. We did that. Velocity in what? Meters per second. Okay, what else must you do? Remember, velocity is the one with direction. So velocity is the one with direction. Okay, one with direction. So that will make our momentum also a vector. Okay, so our momentum also becomes also a vector, because we are saying momentum, velocity does have direction. So whenever you're given a scenario, you must always know that I must know the direction. You must give direction. Your value must be have what called always direction. Okay, it must have direction. Let's give an example here. Let's give an example of what called let's give an example of a cricket ball of mass 160 grams. A cricket ball of mass 160 grams. Okay, it's bowled at 40 meters per second. Okay, towards batsman. So it's towards what called towards batsman. Okay, batsman. Okay. Now we want to calculate the momentum of the ball. Calculate what you call calculate momentum. So what must we do? We know that what are we given here? We're given mass. Mass is in what? It's in 160 grams. We must divide by 1,000. What must we get now? Let's see our calculator here. We are saying 160 divided by 1,000. Then we get what? We get 0.16 kg. Okay. Then let's see velocity. Velocity must be in what? Velocity is it's fine. It's 40 meters per second. Then what about direction? In terms of direction, what must we say in terms of direction? We are saying your V. Remember, let's choose positive towards batsman. Understand? So you must choose a positive. So what we have here, so we know that momentum is therefore equal to M times what? Times V, which is equals to M is 0.16, okay, times 40 meters per second, which is going to give us what? 0.16 times 40. What do we get here? We get 6.4 kg meters per second towards batsman. So because it's still positive here, so it will be towards the batsman. So that's what you must get. That's what you must get here. Okay, that's what you need to understand when I talk of what you call basic momentum, basic calculations. Okay. Now let's talk of. Remember, I spoke of change in momentum. Change in momentum. Okay, change in momentum. So we know that you're right. Momentum, what changes is velocity. What is velocity? We'll always have an initial velocity and final velocity. If something you are traveling, you are approaching the robots, let's say you're traveling, you're approaching the robots, remember, you need to reduce your speed. By reducing your speed, you're reducing velocity. So it means that you had V1, you had V, it means that you have V initial, okay, before you actually saw the robot. Now you're approaching the robot and you need to reduce your speed or to stop at the robot. So what is it, the V final now? V final will be 0 if you have to stop. So always know that when an object starts from rest, what must be our V initial? V initial, this is initial velocity. When we say Vi, it means that initial velocity. Okay? Then, so if we are saying it starts from rest, you know that it's initial velocity. It comes to stop or rest. The car comes to stop or to rest after the collision. What will be V final? That's a final velocity. So here V initial will be equal to 0. So here it's final velocity. It means that final velocity. Okay, and so it means that the V final here is because it's what called it's V final here is what it's 0. That's what you must understand there. Okay, that's what we have there. That's what we have. So let's see what happens now from there now. What is change in momentum? We say now change in momentum is equal to P, your final momentum, minus your initial momentum. Okay, so what do we have here? Remember, it's mv final minus mv initial. So remember, we have got same m here. M is common, so we can factor out m. Then we have v final minus v initial. That's what you must always have. Okay, that's our change in what is it? Our change in the momentum. So that's change in what? Change in momentum. Change in momentum. Okay, so let's now you have an understanding here. What must you do? You must always, given every scenario, you must be able to determine what's your V final initial velocity, what's your final velocity, and the mass doesn't change. Okay, you deal with the same mass. Okay, so let's see what is the vector nature of what called of momentum. We did that because we said the vector nature is actually the direction that we're talking of here, magnitude in direction that we're talking of here because of velocity. So velocity is actually what changes what we call momentum. So remember, your momentum, you change your momentum by increasing either mass or velocity. You change your momentum by changing what you call increasing either mass or velocity. So changing those two things, it actually what you call it's actually so it's actually does the effect on momentum. Let's give an example here. Just one, I forgot something. Let's give an example here of what you call a mass, a car with a mass of so we're saying a car with a mass of 1000, okay, 1000 kg, okay, and is traveling at what called 8 meters per second. So V is equals to 8 meters per second, okay. Then traveling east, okay. Now, and we have a truck, or a motorcycle, motorcycle also traveling east, but here the mass is what? Mass is 250 kg, okay, but the velocity now V is 32 meters per second. So remember, momentum we're trying to measure, it actually indicates how difficult an object, how difficult it is to bring to rest or bring to stop. So here we would assume that if these two are to travel with the same speed, if they are to travel with the same speed, the car will be difficult to stop, meaning the momentum of the car is greater. Then the motorcycle will be difficult also it will be easy to stop because of momentum will be less. But now let's see, if now we have to increase the momentum, the velocity of the motorcycle. What we'll get here? We will get to see that P of momentum of the car is going to be 1000 times what? Times 8. Okay? Then it's going to give you what? Which is going to be 8000. You don't need to calculate that. Okay? Kg meters per second. Now, here also that when you are given what for the motorcycle is 250 times what? 32 meters per second. So let's see. Oh, sorry. 250. Okay. Apologies, I don't have a calculator, but you can just need to opt to this. Okay. So it does, we have 8,000 kilometers, sorry, kgs per meters per second. So that's what we have. That's what we get there. So it means that you see, if you are to change, if you are to increase the speed, it will also increase the momentum. In a sense, if you are to lower the mass, what happens that it will also lower the momentum. So it does depend on the what you call on the mass and velocity. Okay, so let's check on the vector presentation, the vector diagrams of momentum. So here, let's have an example here of a bouncing ball. Bouncing ball. Want to see change in momentum in what call in terms of in vector presentation. Now let's have a ball here. Okay, we have a ball. Okay, we have a bouncing ball here. It's moving towards the wall. This is a wall. Okay, now what we have here, this is our what call our initial momentum towards what call the ball moves towards what call towards the wall and bounce back. Okay, so how do you represent that in terms of what is in terms of vectors? So we have our vectors here. We say here our P. Okay, so here you find that here what we have here is that your P initial is towards the wall, but your P final here is coming back now. So what will be the change in momentum overall? Change in momentum is actually moving, your ball is moving to a what called different direction, isn't it? Moving on another direction. So you find that in most cases, in this case here, your change in momentum will be negative. If you are to choose the direction of what called direction of the wall towards the wall is positive. That's what we have here. So this is a bouncing ball, and that's how we represent in vectors. So vectors here show that this one goes to the right, which is positive. Then the other one now, in terms of P final, is now moving to the left. And when it's moved to the left, it's just showing the negative. It's just showing the negative. So we would understand that here will be our center of maybe 0. Then we are moving to from 0. We know that from 0 here, what do? We move towards the positive, and from here move towards what we call the negative. Here, let's give an example here. Let's say the P initial. Let's say P initial was what? P initial was 20 meters per second. Then maybe P final was equal to maybe 10 or maybe 15 meters per second. But here in this case, it will be negative 15 because it's going on the negative direction. If we are to choose your towards wall, positive, towards wall. So what will be our change in momentum now? Change in momentum will be equal to P final minus P initial. What do we get that? We see that P final is, P final here will be equal to negative 15 minus what? Minus 20. Then you get minus 35 meters per second. That's what you'll get there. That's what you'll get there. So you find that this is going to be negative, and when you get negative, what must you conclude now? You say it's now 30 is 35 meters per second away from the Whoa. That's what you conclude there, because away from the wall means it's negative. That's what you are doing. So you must always show that it must be negative. Then the sign does matter, and from there, when it's negative, you know that it's away from the wall. The side that you choose that is negative. Okay. Now let's come back to Newton's second law in terms of momentum. Okay. So what does it say in Newton's second law of motion? Okay. So Newton's second law of motion now states that uh, resultant or net force that acts on an object is equal to the rate of change in momentum of the object in the direction of the resultant force. So always remember, like what Newton's second law says, if you are to push this phone, this is the net force, because when it's sitting like this, there is no net force on it. Okay. So when I apply an external force, that's the resultant force. When I apply a force like this, I am pushing it toward that side. So it will move also toward that side. Okay, so in terms of also momentum, the momentum will change towards the direction of my F net, of the F net or resultant force or applied force. Okay, that's what we'll have there. So that's what it says. So we know previously that F net is equal to MA. F net is equal to MA, okay? And your A, which is acceleration, is acceleration. Acceleration is equal to change in velocity over change in time, okay? Okay, and change in velocity, remember, change in velocity is change in V final minus V in what? V initial, okay? V initial over change in time, okay? That's what we have there. But now, let's check here. Let's take this one back now and see what we have now if we have done. It means that we have M change in V, okay, over change in time. And when we check this, what is MV? What is MV? MV is change in momentum. So in other words, we are saying your F net, whenever you want to calculate the F net, the net force that is applied on an object will depend on the change in momentum and also the time. So the time it will take for the momentum to change on an object is actually the force. Let's give an example. I'm just going to show you a good example here. We are saying here, if someone is to hit throw a tennis ball or hit you with the tennis ball on your head. Imagine if you are to throw the tennis ball maybe at 10 meters per second, okay, and the other person to throw it 50 meters per second. So who will feel more pain here? It's probably this person here. Will have greater F net. Okay, that's the photo we're talking about here. How now? Because if it's coming with this high speed, with this velocity, it will spend less time. So once we reduce the time here, if the time is less, okay, it will probably have we probably have more pain here. If it is slow, if someone just throw with the 10 meters per second, you won't feel much pain. And also we find that the tennis ball or the ball will be in contact with your head for longer time. And when you have got more time here, it means that the final value here will be what? Will be less. So once we have got low, this one is low, okay? This one becomes great. That's what you must know there. That's what you must understand there in terms of what. Okay, so remember we are talking of F net, we are talking of Newton's second law, and we're saying it does have an effect on on the momentum. Now we want to see how the change in momentum when F net acts on an object and its velocity. So they are different effects on effects on the momentum due to F net. Let's give an example here. Remember, the force can either increase momentum in the direction of motion, okay, or it can decrease it can decrease the momentum, okay, or it can actually go the opposite way, direction of motion, okay. It can actually goes opposite or reverse direction of vertical momentum. We want to see what are these forces that can do that. Now here, force that can increase the direction of motion, what you need to understand in the example is a rocket engine fires. Rocket engine, so let's give an example here. A 10 kg model rocket is launched from rest and reached a velocity of 42 meters per second in 7 seconds. Okay, this is a result of the upward force of the exhaust gases. So remember, the direction of direction of your rocket is actually upward, isn't it? So what happened in that is that the gases, exhaust gases, are actually that the one that pushes what we call the rocket upward. Okay, so we want to calculate here change in momentum, in this case. So what do we understand by change in momentum? Change in momentum, we know that change in momentum is your P final momentum minus initial what? Initial momentum. So what is this? It's M V final minus V initial. Remember, let's have something here. What did we say about the direction? What is given to you here? Let's take positive as upward. Okay, then we say the velocity, initial velocity, because it starts from where? Starts from where? Rest. So what must be our initial momentum? Initial velocity is 0. Final velocity is what? 42. It reached 42 meters per second. Now, what is our time? Change in time is also 7 seconds. Okay, so now let's use what is available to us here. It's gonna be M. Okay, our m is equal to what? Our m is mass is 10 kg. That's a good thing because already we don't need to convert anything. So v final is 42 minus 0, which is equals 10 times 42, which is gonna be 420 kg meters per second. Okay, now let's go on to the next question. Calculate the net force F net explained by the object. We know that F net, we did that. F net, we did that. F net, we have proved that F net is equal to change in momentum over time. So over change in time. This is change in momentum over change in time. We have change in momentum already, which is 420. Okay, over change in time. What is change in time here is 7. So what is that? So we come to our calculator here and see what's going on. 420 divided by 7. Okay, what do we get? We get 60 Newton. Okay, what is this speed? Oh, remember, here it's going upward. Sorry, here it's going upward. Okay, here 60 Newton also upward. Remember, also because remember F net is your force. Force is a vector as well. Force is a vector, so it must also have direction. Momentum, vector, direction. Okay, so let's move and see what is the second scenario that we can have, that we can experience. We can also experience that the F net, the resultant force, can also decrease the momentum. How does it look? If you brake, remember, if you put brakes towards when you're approaching robot, what are you doing to the momentum? You are decreasing momentum. Okay, so when you're decreasing momentum, we want to see how is it like that. Now let's see here. A car, okay, of a car 800, that was 800 kg, moves east at 25 meters per second. Okay, a braking force applied by the brake FA as well as frictional force FF decrease the velocity of what of the car to 10 meters per second within 6 seconds. Okay, within 6 seconds. What we are doing here, remember, we are decreasing momentum. Now here, what is going to happen here? Let's see what we're supposed to do here. We'll check here and see. All right. Calculate change in momentum. We know that change in momentum is what called V initial. So let's take our east as positive. Our east is positive, as we can see, our east is positive. V initial 25 is plus 25 meters per second. What is V final? It's also plus, because remember it's still in the same direction. It's 10 meters per second. Okay. Then what is it? What is the time change in time? Is equals to 6 seconds. Okay. Now what are we left with now? With mass is equals to 800 kg, which is fine with us. Now, let's see here what we're supposed to do. It's going to be 800. 800 times what? V final. What is V final? V final is 10. Okay, 800. So what is our V initial? Is 10. V final, sorry, 10 minus what? 25. Okay, what will be your answer here? Let's see here. It's going to be, let's see, 800 in brackets, you have 10 minus 25. Okay, what do we get here? Minus 12. 4,000 kg. Okay, so what is minus? What does minus mean? It means that is 12,000 kg meters per second west. Remember, it's negative, so it's actually changing towards west. Okay. Now here, what is F net? F net, remember, we're not going to take much time here. F net, what is F net? F net, remember, F net is equal to change in momentum over change in time. What is the change in the momentum here? It's negative 12,000. Okay, over what? What is change in time? Is 6. So we take that negative minus divide, sorry. All right, divided by 6. What do we get there? We get negative 2,000 Newton. So what does negative 2,000 Newton mean? It means that is 2,000 Newton west. Remember, what we are saying here. F net is acting against motion. It's frictional force, it brakes, they act against motion because you want to stop the car. That's why you are getting a negative here, because it's acting against direction of motion. Okay, let's see the third scenario here, which is the last scenario. Now here you can also have reverse. Okay, reverse is direction of motion. Momentum can be reversed, isn't it? So you can also reverse direction of motion. The direction of motion can also be reversed. Remember, here on these two scenarios that we did here, there was no reverse in direction of motion. It's still going east. It's still going here east, but it's still going here east. But the thing is that the forces that are acting are against direction of motion. Okay, so here let's see what's happening here. What happens? What's a good example here? If you are to kick a ball, if you are to maybe you pass a ball, okay, you pass the ball towards a goalkeeper, okay, a goalkeeper here, okay, a goalkeeper here. So the goalkeeper will kick the ball back with a certain momentum. So that's the change of direction, because the first direction was toward the goalkeeper, and now you kick the goalkeeper, kick the ball backwards. So it means that now the ball is changing direction. You understand? Now let's give an example here. So a very good example. If the force can also change direction. So example is a soccer ball kick back in the direction of what it came from. Now here, a soccer ball with a mass of 200 kg. So let's see what is given. Mass is 200 grams, which we say 200 divided by 1,000. Remember, it gives you what, 0.2 kg. We're done. Then we say V initial rolls toward the goalkeeper, okay, at a velocity of 8. So V initial is equal to 8 meters per second. Okay. Now he kicks it back at a velocity of 5. So V final is actually what we call 5 it minus, now remember, minus negative, because it kicks it back, it's going to the negative direction. So it's actually minus 5. Then here, calculate change in the momentum of the ball. Now we know that change in the momentum is equal to what? M V final minus V initial. Okay? V final minus V initial. What is our mass? Our mass is 0,2. What is our V final? Negative 5 minus what? Minus 8. Okay? What do we have now? We have 0,2 in the bracket. Okay? Negative 5, negative 8. Okay? What do we get? We get negative 2,6. Negative 2,6 what? Kg meters per second. Here, remember, we choose to say here, so towards positive is towards goalkeeper. You understand? Towards goalkeeper. Sorry, spelling. Towards goalkeeper here. So it means that when it's negative, is 2,6 kg meters per second away from the goalkeeper. Okay, that's our final answer here. Now let's see the next thing here. Calculate the force that the ball exert on the what? On the soccer player, foot, if it is in contact with his foot for how many seconds? 0,1 seconds. What must we know? We spoke about this. We spoke about this. So what must we do now? What must we do now? We know that change F net is equal to change in momentum over change in time. What is our final answer here? Change in momentum, we got it already, 2,6. Okay, what is its negative? Remember, what is our time? 0,1. Okay, then what is our answer here? So we say the answer there, okay, divided, negative 2,6, okay, divided by 0,1. What do we get? We get 26, negative 26 Newton. Always remember your force is in Newton. What if it's negative? It means that it's 26 Newton away from the goalkeeper. Okay. So that's what you must master now. So when you're dealing with momentum, first of all, remember this is our end of our end of the lesson. On our next chapter, we'll be talking of what? Impulse and conservation of momentum. Okay, so here I think I break down everything that you think you need to understand, the basic that you need to understand in terms of when I talk of when I talk of momentum, what is it that we are talking of? Remember, objects that are traveling at a higher speed are difficult to stop. So it means that they have greater momentum. Objects that are traveling slowly, they have less momentum because they are easy to stop. So objects also with high mass, they are also difficult to stop, like a truck which is weighing 5 tons. It's difficult to stop. And objects with a lesser mass is also easy to stop, which means they have got low momentum. So again, remember to include direction. Always, first of all, determine what the positive side, where is your positive side, and remember to put negative. Whenever you have an answer is negative, it means that the side that you choose as positive, that object is moving away from it. Okay, if you are seeing a negative. Okay, so until next time, thank you so much. Have a good day.